Today we're going to talk about the BTF lighting panels, which I've got from Amazon.com. They're 22 by 22 LEDs. They're consist of the WS2812B chipset, which is to say there's an integrated circuit at each LED location. These panels are relatively new in that they've only been around for a few years. They're very unique in that they're extremely thin. You see they're thin and they're flexible as well. This is what's necessary for the Murgetroid, because what it allows me to do is to place two panels back to back with a plexiglass panel in between that these are mounted to, and by putting them back to back, effectively I have created one LED location using two panels, and that means that as the panels rotate, I'm able to see any LED throughout the entire rotation. If I only used one panel, I'd only see it half the time. So effectively I've created one location for an LED by using two panels. And what you're seeing here is how the panels come. This is one panel, and you'll notice that there's not that many wires to talk to 484 LEDs 22 by 22. There is basically a red wire, which is the power, 5 volts, and the white wire, which is ground, and the green wire here, which is the data. There's one data line to talk to all the LEDs, which is extremely interesting, and we'll talk about that in a second. Now I've turned the panel over, and you can see I'm running through a test where I'm lighting one LED at a time, and I'm going through all 484 LEDs in sequence. The very first LED is over here at the 00 location, and then the very last 484 LED is over here. It runs in a serpentine pattern, which is how these panels operate. You can also buy these LED as chains, and you can often see them that way, but they're all serpentine. What it means is that the data that is used to talk to each of these LED addresses is in the form of an array. In this case, it's an array of 484 locations. And by writing to a particular location in that array is how I talk to any individual LED. So to talk to this LED over here, I write to location 00. To talk to this location over here, I write to location 483. And you can, the fact that it's got one data line means that in order to talk to this very far LED, I have to pass data all the way through all of these LEDs. They hand off one to another in a bucket brigade fashion. And because it's a bucket brigade, there's a limitation on how quickly I can light these LEDs. In fact, right now you see it's running through at the very fastest update rate possible for 484 LEDs. That frame rate is about 69 frames per second. Turns out, though, that if all I do is choose to light the very first 22 LEDs, the ones that occur on this edge of the panel, that I can get a much faster frame rate on the order of 436 frames per second, which is about 6.32 times faster. And that's extremely important when I try to write text using the Murgetroid, in which case the text appears on the outside edge of the Murgetroid, because I'm able to get a much faster frame rate with these very first LEDs. And I switch between lighting the first 22 versus all of them, and I can go back and forth between that in order to get the various effects of the Murgetroid. Turns out also I can light the very first 22 while leaving the rest of these already lit without degrading the frame rate, and that gives us some very interesting effects. So when you test these LEDs, make sure that you mark the location of the very first and second LEDs in order to allow you to line the outside edge of the Murgetroid with the very fast LEDs. And you will find that when you do that, you'll have one edge is right side up, and then the other will be upside down on the other panel. So now I've got the two panels of the Murgetroid. There's 4 of them total, but 2 of them at a time here that I've stripped the original wiring from, and I've added my own wiring. And you'll notice what I've done is I've connected the data line here to route down over here, and all the wires are eventually going to come through the middle of what will be the spinning part of the Murgetroid. So this is the spin axis right here. So all the wires are going to have to come right down through the middle of the spin axis to feed into the main electronics of the Murgetroid box. So to do that, also I've routed, since there's a lot of excessive grounds and supply lines, 5-volt supply lines on these panels, I've simplified them. Now there's only one supply, and 5-volt supply, one ground, and I have the 2 data lines, the green and the yellow data lines here. And I've added a couple extra wires in here to bus the 5 volts, connect them together. You don't need to do it in too many places, even necessarily at all, I'm not certain. But there is a fair amount of current that these panels draw. They can draw up to about 5 amps, so they're extremely power hungry. So you have to be careful about the power distribution. I tied together this wire here for the 5 volts, and there's a wire there for the ground. Similarly over here, notice what I've done also is marked the 0 and 1 position with a line, and the 0 and 1 position with a line over here, and they are upside down from each other. These 2 panels, in order to have the fast LEDs we spoke of on the outside edge of the panels, you need to have one of the panels be upside down. That's going to require a data translation in the software. It's not a big deal, but something that you should be aware of. One other cautionary note here is that when you test these panels, you do not want to light all of the LEDs at the same time using just the supply current from the ESP32 board, which is what I was using to drive the LED panels. The reason is, of course, that the little ESP32 board cannot supply the power, the USB connection cannot supply the power needed to light all the LEDs. So I've been lighting, you can maybe light a row, but I wouldn't light much more than that. If you do, what will happen is the ESP32 will get too much power drop to it, and it'll do a power on reset, and you won't be able to light the panel at all at that point. So just a cautionary note on that respect. I mentioned that I'm using the ESP32 processor board to drive the panel, and you want to make sure that the processor board has a level shifter at its output, because it operates at 3.3 volts on the input-output of the pins, but the LED panel wants to see 0 to 5 volts, and to do that you'll need a level shifter. Lots of them out there on the market. I think I used one from SparkFun. We'll talk a little bit more about that, I guess, in the future, but that's just another thing you'll need to keep in mind. And it is important that you test these panels because they are flexible, and when you test them you want to bend them a little bit, not a lot, but bend them a little bit, because the wires, you want to make sure all the wired connections to these LEDs work. I have had a bad panel in the past, and the company is extremely good about their giving you panels even after the date when you may have not been able to return it, but it's always a good idea to test them in advance to make sure these things light. They're not cheap. They're about $60 to $70 I think each, and you're going to need 4 of them for the Murgetroid. So I think that's all I have to say about the panels, except that as I mentioned, these panels dominate the performance of the Murgetroid. If they were able to update much quicker, I could do a lot of interesting patterns with it. But as it is, there's a limitation, as you can see, on the speed at which I can get a frame rate on lighting the entire panel. I can play tricks with it by limiting the number of LEDs that I choose to light, and that's something I'm going to be exploring more in the future. Right now I've limited myself to the outside edge of 22 LEDs, and the rest would be the full panel. So I'm going to try exploring with LEDs in between, but that's at a future date. Thank you for watching this.